Okay, recording started. Hello, everyone. Welcome to CNCF Ahmedabad. This is the virtual project tour session that we have been doing on pretty much monthly basis. This time we have Bill Mulligan from Isovalent, which is now a part of Cisco, joining us to discuss eBPF and Cilium. But before we get started with his session, I see we have a few people joining from around the globe. So uh, very quick look at the map about where we are based out of. Ahmedabad is in the western part of India, just so that it helps give a perspective about where we are physically located. And the time zone is UTC plus 5:30. Uh, for what I think is good reasons, we don't follow DST, so things don't get messed around over here when it's winter time and summertime. Um, this episode is a part of CNCF Projects Tour that one of our co-organizers came up with, the idea he had. And what we do over here is we invite maintainers and contributors. Mostly we try to get maintainers from different projects come talk to us about the project they are working on. Um, and the only prerequisite we kind of keep is that this project should be a part of CNCF landscape. So that's a part of l.cncf.io. We started with Jaeger. We had Falco come talk to us. We had Kiverno, GitOps, a lot of people so far. And Falco was probably our first introduction, not probably, but definitely our first introduction into a CNCF ecosystem project, which was doing something around eBPF. So after that, it's Cilium today. And if you're looking for the playlist, if you're looking for the past episodes, this QR code, you can take a quick screenshot. This contains all the past sessions that we have had so far. And with that, I think I'm going to quickly give it over to Bill. He's going to talk about Cilium and eBPF. He's community pollinator. Bill, I'm going to have to ask you to explain what that means. He's also governing board member Isovalent and at eBPF Foundation. If you folks have never heard of eBPF or if it's your first time, then yeah, fasten your seatbelts. It's a pretty amazing piece of technology. I mean, I have only recently learned about it and I just can't stop being amazed, shocked, surprised at all the things that it's capable of doing. And on the CNCF Ahmedabad side, we are three organizers. Shivlal, who I think is not a part of the call today, he had to take care of some medical emergency. Sandeep, he's right there. And then it's me. Um, so with that, I'll hand it over to Bill. With all yours.
Cool. Thanks for having me today. And it's nice to meet everybody at the meetup. I hope you're enjoying your evening, afternoon, morning, wherever you are in the world. So yeah, and I kind of think we said this at the beginning. Please feel free to stop me at any point if you have any questions or just like drop it in the chat. I'm always happy to answer things. Oh, we have someone from Brazil, right? So it's awesome. Very, very much morning there. So yeah, I'm Bill Mulligan. I'm a maintainer of both Cilium, which is a graduated CNCF project, and eBPF.io, which is the kind of community hub for the eBPF project, which is part of the Linux kernel. And I'll kind of like walk through what each of those are. So the first one, let's see. We're gonna, since this is CNCF meetup, we'll talk about Cilium. So if you haven't heard of Cilium before, Cilium began as a CNI. So when you're installing a Kubernetes clusters, Kubernetes is really great because it can manage the whole life cycle of all of your containers. But the thing that it doesn't come with out of the box is networking. So right, we have this whole paradigm of distributed computing, lots of containers running on lots of different machines, but they're not actually connected to each other. So you can't do anything until you install a CNI or container networking interface that provides the pod-to-pod connectivity. So at a very basic level, what Cilium allows you to do is provide networking in cloud-native environments. Since kind of like the beginnings of the projects is now almost 10 years old, actually. It'll be 10 years in December, so it's 9.5 years right now. It's expanded from kind of that like simple mission to be a Kubernetes CNI to covering like the whole networking stack and also including observability and security. So where we're going to kind of go through right now is like the Cilium homepage is where we'll start. So I'm just dropping that in the chat so you can kind of follow along if you want to also. So I guess like the first thing, if you aren't familiar like with Cilium, it's good to know kind of like it can be interesting to know who's using it. And Cilium has really become the standard or like the de facto standard for cloud native networking. If you go to the top here to the users, you can see this is our adopters page. And here you can kind of see all the different talks, case studies, the blogs that people have written about their use of Cilium. Cilium is also, beyond kind of like these end users, it's the standard for almost every single cloud that you can have out there. So if you're spinning up a Kubernetes cluster on a cloud in lots of different places around the world, you're probably going to get Cilium. If you have a favorite Kubernetes distribution, it's probably using Cilium too. And there's lots more end users of Cilium too. So I always like to start with this page because it kind of gives you a sense of like how widely deployed Cilium is. And that's kind of cool for me working on the project. And so what do these users actually use Cilium for? So we'll kind of dive through some of these features one by one. So the first one I was talking about was the CNI. So Cilium provides like the pod-to-pod connectivity, and it does this with a Linux kernel technology called eBPF. Now, has anybody here heard of eBPF before?
Yep, a lot of us.
Okay, that's cool. So eBPF is this Linux kernel technology, also now a little bit over 10 years old. So Cilium and eBPF kind of grew up together, which is always kind of fun. And if you aren't familiar with eBPF, I'll switch over to the eBPF homepage. I'll jump over to that so you can kind of get an understanding of what it is. So eBPF allows us to dynamically program the kernel. So what does it actually mean? So the Linux kernel is not a 10-year-old technology, not a 20-year-old technology. It's like an over 30-year-old technology. All right, so if you think about 30 years back, you know, some people may not even be alive yet. You can think how much kind of technology has changed in the meantime. And so what we're kind of dealing with this monolithic kernel is, you know, something that's like slow to change. Linux is deployed on billions of devices worldwide. You know, it's like has a steady release cadence, but you know, things can't change too fast when you're deployed that widely. And so what this kind of did is it slowed down the whole innovation cycle in the kernel. It wasn't quite moving as fast anymore because it was focusing more on stability. But we wanted to be able to add programmability back into the kernel. You know, there's lots of different use cases that people have if you're deploying on a mobile device versus deploying on a server in a data center versus deploying into, I don't know, like a manufacturing center. So one of the questions that was kind of like facing the kernel community is how can we have both stability and the ability to innovate too? And this is kind of where eBPF came in. And so the comparison that people like to do is like eBPF is to the kernel what JavaScript is to the browser. And so if you kind of like think about what that analogy means, right? Rather than having a static web page, suddenly with JavaScript, you can have interactive elements that like change and are dynamic. And as you like interact with them, they change how the actual website functions. And so like what eBPF allows you to do is to insert little programs into the kernel. And when those things are, you know, not clicked on, but like activated, the system calls that your application is making, suddenly you can reprogram the kernel on the fly. And it's not just that, it's being able to do it in a safe and efficient manner too. And so that adds a lot of ability to innovate back into the kernel. And that's why it's becoming like such a powerful infrastructure technology, because it allows us to rethink all of our system infrastructure, because we can reprogram it to do exactly what we need. And so the way that Cilium kind of does this is first use it for networking. So if we go back to like the CNI page that I was doing before, right? The Linux kernel networking stack has 30 years of history in it. So this diagram on the left, you know, there's a lot of routing tables. There's a lot of overhead going through the Linux kernel networking stack. But with eBPF, we have a lot of intelligence about what is actually happening on our system. We can see everything that's happening. And in a lot of ways, we're able to skip or only use part of the Linux kernel networking stack when we need to. So this really provides a lot of high performance and scalability to your networking infrastructure. When Linux kernel was designed, it was a different world, right? A lot of people were running just things on single machines. Now we're running on thousands or millions of machines. And the question is, like, how can we keep up with this dynamic and scalable environment? Ephemeral containers are coming and going. IP addresses aren't changing. And Cilium enables you to do that by leveraging eBPF. And on top of that, since from starting as a simple networking CNI, Cilium has really expanded into a lot of other things too. So the ones that people may be most familiar with is, okay, so you're connecting your pods together, but what happens if you have a second cluster, right? And you need to connect the two clusters to each other. So this is where Cilium comes in, and it provides a way to mesh multiple clusters together. Now, one example of where that's useful is being able to have high availability or fault tolerance. So if the backend service in one cluster dies, then that cluster can fail over to the other cluster and keep being served. You're able to essentially show different backends across multiple clusters. So even if it isn't available in their cluster, it can seem like it is available locally to your pods. So sharing services across clusters, and then being able to do things like network policy enforcement, encryption, service discovery, and load balancing in a unified way across multiple clusters. Another main reason that people like to adopt Cilium is for the kubeproxy replacement. And so what kubeproxy does is it proxies between different services in your Kubernetes cluster. And so what Cilium's kubeproxy replacement does is it replaces the standard kubeproxy with an eBPF-based implementation. So kubeproxy is based on IP tables, which is an old Linux kernel technology that's built for kind of single machines where you literally have these chains of rules kind of going through, and you have to iterate through each of them. eBPF allowed us to once again fundamentally redesign how we wanted to do this. So rather than having to go iteratively through a whole chain, you can have a hash map. It's much more efficient and scalable. I think one of my favorite nuggets about Cilium is that it's being used to power, here it is, AI models, doing a lot of training. The scalability and performance you get from eBPF allows people to train AI models on 65,000 node clusters. So when you think about performance and scalability, that's really the pushing the limits, and Cilium is able to help people do that. Another main reason that I see people adopting Cilium is, right, you already have it installed as your CNI and you want it to manage the rest of your networking stack rather than having to manage a bunch of different point solutions. And so Cilium does things like ingressing traffic into your cluster. So when you have, somebody's trying to access your web domain, the request is coming in, Cilium provides an ingress into your Kubernetes cluster so people can access whatever they want to. On top of that, it can also egress traffic back out of your cluster too. So a request comes in and there needs to be a response, and it needs to go to a specific IP because you have a legacy database outside of Kubernetes. Well, with the egress gateway, you can route all the requests through that specific IP. So it looks like that service is being contacted from just a single user, or from a single IP. Cilium has lots of other networking features like service mesh, gateway API, BGP for integrating with top-of-rack switches, but I won't kind of dive into all of those right now. But if you check out the website, there's lots more resources to get started there. And then the next area that Cilium goes into is around the service map. So what Cilium provides is a lot of observability, right? So in a world of distributed computing where all of our essentially processing is going over the network, this pod is talking to that pod, it's making a request here. You need to be able to observe that network traffic to understand where there's any bottlenecks or drops or problems in your network. And Cilium provides a couple different things. It has another sub-project called Hubble that provides flow logs, essentially taking the information off of the wire from Cilium and allowing you to see where packets are being dropped or denied because of a network policy. You're able to debug your network traffic a lot faster. On top of that, it can take these network flow logs and surface them into the Hubble UI to give you a service map of what's actually happening in your cluster. And so a lot of people like this because then they can see how traffic is actually flowing through their cluster visually. And then I would say the last key part around Cilium is around security. I don't think I can understate how important security is right now in the digital world. And so there's kind of like three main things that Cilium has. One is transparent encryption. So what this allows you to do is a lot of like regulatory frameworks ask for encryption of data in transit. So essentially, as it's flowing over the network, your data has to be encrypted so that if somebody's watching the network traffic, they can't just read it. It's still encrypted. And so essentially with one flag, Cilium allows you to encrypt all of your network traffic with either IPsec or WireGuard, depending on what you want. And then the next thing around security is around network policy. So network policy is becoming, more and more important, like who can talk to who in your cluster. And Cilium takes kind of like, I would say, a different approach, like a more cloud native approach to implementing network policy. So rather than relying on IPs, which we really see as ephemeral in the cloud native world, Cilium instead gives everything a label. A lot of things in Kubernetes are tagged by an identity, a label that you have. And based on those identities, Cilium is able to apply not just routing of the packets, but also the network policy on top of that. So essentially, front end can talk to back end, or front end A can't talk to the back end B. Looks like we have a question right now. So before Cilium embraced eBPF, what was it using for networking? Was it also using a sidecar proxy, or Cilium from the start itself used eBPF? Yeah, so this is kind of going back to what I said at the beginning, right? They're both about 10 years old technologies. And the founding team of eBPF, or at least part of it, was also the founding team of Cilium. And so they actually built the whole project from the ground up on eBPF. There's never been another implementation of Cilium. It's always been just eBPF based. And that sets it apart from a lot of other CNIs that you see. I think another fun fact about Cilium is actually in the beginning IPv6 only. These are really some like intense kernel engineers, but they quickly realized they also needed to add IPv4 support. So Cilium allows you to run IPv6, IPv4, or dual stack environments now too. So let's see, I'll open up the chat again. Yeah, oh yeah, thanks, yeah. Yeah, like I said, I'm happy to answer any questions that you have live. I also see here, there's a link to the eBPF documentary. This is another resource I'd really recommend.
The idea of eBPF and making the kernel programmable was immediately super interesting. This is gonna not only change what we were working on right now, but it will also change the industry forever.
So if you haven't seen the eBPF documentary, that's like a little teaser. I'd highly recommend it. It's a really fun and interesting way to get an overview of like the history behind eBPF and also like why the technology is and the impact that it's actually having on the industry too. The next one, are there some numbers in terms of performance benchmarks between kubeproxy and Cilium? Yeah, there's actually a blog post here on the Cilium blog. I think I can drop this. Yeah, I dropped this in the Q&A. So this blog gives you an idea of like some performance benchmarks looking at eBPF IP tables. And you can see the improvement is actually pretty stark. So I'd recommend looking through this blog if you want to learn more about that. There's also one on the Isovalent blog. that goes a little bit more in depth and is added a bit more too. So I can also drop this in the chat too. So those are two good resources to get started, and I can just share like this blog too. So, and this is what I was talking about before. Rather than going through the whole Linux kernel networking stack, eBPF allows us to replace a lot of that or skip over it. So it adds flexibility into how we're doing things. Yeah, so I can let you read through these blogs by yourself too. So let's see. And then the last part about security is runtime security. And so Cilium recently has another sub-project under it. And this one's called Tetragon. This is all in like the whole like Cilium family. And what Tetragon allows you to do is observe everything that's happening in your kernel. And so eBPF is a powerful technology because it allows you to introspect everything that's happening in the kernel and dig into what's actually going wrong. And so with Tetragon, we're allowing you to hook anywhere in the kernel to understand like what's happening. And the benefit of using eBPF for that is that eBPF is event driven. So what's cool about eBPF is that the program only runs when a specific action is taken. And so this becomes really important in security because a lot of application stuff, application traffic, like syscalls that the applications are making, is totally fine. It's normal expected behavior of the application. Now, you may want to have an alert when, for instance, somebody tries to access like the passwords file or tries to escalate their privileges and have an alert just for that. And eBPF is really powerful because it's not looking at everything that's happening. It's only looking for specific things. And so you can say like, only notify me or only block a process when it's trying to access the passwords file. And so it's really an efficient, scalable way to do security, observability, and also runtime enforcement too. So that's like a really quick overview of Cilium, how the project's gone, and like what some of the updates are. Before I go any further, does anybody have any questions?
Bill, I just posted a question about Tetragon versus Falco because we had Falco in the previous meetup. I think we kind of know that Falco, it just monitors stuff, it notifies you, but whereas Tetragon also takes action based on something malicious happening in the cluster. Is there anything else that we should be aware of between among the differences between the two?
Yeah, so that's like one of the biggest differences is Tetragon also does runtime enforcement. The other thing is like a bit more like in the weeds about like how they implement things. Let me see if I can find the blog post really quick. And really getting into the weeds, it's like, so not all kernel things are done the same. There's different ways to hook into the kernel. And this blog will give you an idea of how Cilium implements, in this case, like file monitoring, and help you understand how like Tetragon's implementation is a little bit different. And it's, I guess you really need to have in-depth kernel knowledge to be able to implement, these solutions correctly. Like eBPF is a really low-level technology. That's the benefit of using a project like Cilium or Tetragon, is it gives you a higher-level abstraction to enable you to use these low-level technologies. And it's like the Tetragon engineers have thought about the right way to implement this too.
Okay, thanks.
Yeah. And then the other one, Cilium having so many different use cases due to its flexibility, what are some recommended learning paths and prerequisite knowledge for someone new? Yeah, so that was kind of actually leads me into like the next part of like kind of this session. So on the website here, there's like this Discover Cilium tab where you can walk through like an introduction to Cilium. It'll walk you through these use cases again, some of the architecture. What I actually want to do is like check out some of these labs, because I think these are a really important resource for the community. So if I click on this like start lab, you can see the community has provided a lot of different labs about how to use Cilium. I think this is like a really great resource if you want to dive into some more of these specific features or get started with them. What's really cool about this is a lot of them are hands-on. And so I'm actually going to do this getting started with Cilium lab. I've actually never done this lab, so this is kind of like a new thing for me. But it'll put us live into a hands-on Kubernetes cluster, and we'll kind of walk through it together. So here we are in this instruct environment. Let's see.
Bill,
Yeah.
Bill, one question. All of these labs, they are free, or like we need to have some credits?
No, all these labs are free.
Okay, awesome.
Yeah, so this is a great resource to get started in learning about it too. So, okay, let's see. Powering up from an app starting soon. So yeah, a lot of these labs are from Isovalent, which is the company that I work for. And you can see all the different labs on this map. I think this is like a pretty cool thing that they put together. It's like the world of Cilium, and it's like Mesh Island or Operations Island or the Networking Island. It's a really cool way to think about like your learning journey through Cilium. So let's see, let's get started here. So you can see there's the terminal on the left side, which is like your hands-on environment. And here's what's happening on the right side too. So it'll kind of like walk us through this. So here we have a lab environment, and let's look at the configuration, right? So it looks like we have a couple nodes. So there's the control plane and 2 worker nodes, which is pretty cool. And then in the networking right now, we can see that the default CNI has been disabled. So there's not actually any networking in it right now. So that's happening because we want to install Cilium. So let's make sure let's see if our pods are ready. We can see that all of our nodes are in the not ready state because there's not a CNI in it right now. So you can't schedule workloads because they won't be able to communicate with each other. So here we go. So there's multiple ways that Cilium can be installed. The main way is either the Cilium CLI or with the Helm chart. And the CLI also allows you to add additional features later on, such as like Hubble or like cluster mesh. So let's see. Now that we have the Cilium CNI, let's run Cilium install. And we're just waiting for this to install. We can check what's happening. See, it's not quite spinning up yet. So obviously okay, I'll jump over to the questions right here. Another question. So why aren't other service meshes also opting for eBPF? Why are sidecards still being actively used when it's crystal clear that the advantage provided by eBPF is just unmatchable? I think there's multiple reasons for that. So if you aren't familiar with like the Cilium service mesh, there is a blog post on the Isovalent blog about this. Let me just pull it up. Oh, whoops. Sorry, I thought I had it pulled up. Okay, here's the blog post. So in Cilium Service Mesh, not everything is actually done with eBPF. It actually has either eBPF or sometimes it falls back to Envoy for layer 7 processing. So it really depends on it depends on like what type of networking traffic that you want. So eBPF is really good for layer 3 level, layer 4, but some of the layer 7 network traffic is processed in Envoy. And that's a node-based proxy. But I would read through this blog to learn more about it, actually. So I'll drop that in the chat too.
Okay.
Yeah.
Thanks, Bill. So one follow-up question. So given that eBPF is layer 3 and layer 4, is that the reason that Cilium is actually using Envoy for layer 7?
It's using Envoy for layer 7 sometimes, yeah. And Cilium has its own fork of Envoy.
Okay. And then how does Cilium take care of like MTLS and everything, because MTLS is at level 7?
Yeah. So I would read through. There's another blog that we have here that will walk you through how MTLS works in Cilium. And so the way that like mutual authentication works in Cilium is it separates the handshake and the actual encryption of the network traffic. So the encryption is separate from the handshake, but I won't dive into the details of that. I'll just like have you read the blog.
Okay, thank you.
Yep. Okay. So switching back to our lab here now, we can see now that all of our nodes, they went from a bunch of errors, like things aren't ready, to everything being available. So, yep, it's all ready now. Let's see. So, it allows you to both install it and check the status of Cilium in the cluster. Okay, now we're going to dive into one of the network policy examples so you can see a little bit how Cilium actually works. So we have an Empire demo application that has several microservices with different labels. So we have like the Death Star, the TIE Fighter, and there's a Rebel X-Wing. So this is what I was talking about, like we're not using IPs anymore, we're actually using the identities of the different microservices that are running in our environment. So what we're going to do is apply this, and we can see the different deployments are created. So now we have a Death Star, the service Death Star, the TIE Fighter pod, and also the X-Wing pod. And just to check that everything's going, we can see that they're actually all running. And yeah, they'll go through. Okay. And then what we want to do is actually see if they all have endpoints. And we can also see that the endpoints are here. And these are Cilium endpoints, right? So this is the identity that Cilium has given them. So now that it's installed, let's check like the first things. Okay. So, right, the Death Star, they don't want to be blown up. And so let's see what happens when we request a landing. So the TIE Fighter is going to try to like make a call to the Death Star, and that's allowed, right? Because the TIE Fighter is part of the Empire. But if we try to now land the X-Wing, it's also landing. So the access is allowed. So that's good for the rebels because they want to try to blow up the Death Star, but it's not so good for the Empire because they don't want the TIE fighters actually landing on the Death Star. So how can we stop the TIE fighter from being able to land on the Death Star? And that's what we're going to do now with network policy. So what we're doing here is implementing, right, we have these different labels, these different identities that were given to things, but we want to say, hey, this one shouldn't be able to talk to this one. So what we need to do is like only Empire ships should be able to access the Death Star. So we say you need to be part of the org Empire to access the Death Star. And we want to make sure that they can only do it on a certain port. So if we go to the network policy editor, this is also a good way to see that service map that I was talking about earlier too. And now actually enforcing the network policy. So we're actually applying this to our cluster. Okay, next one. So we can give the TIE Fighter full access to Death Star's API or no access at all, but do we really want to trust all of them? We actually are going to do things that just allow the operations that we want. So right, the X-Wing is going to be able to make a landing request, but it can't hit the exhaust port because we don't want it to do that. But we definitely don't want the Alliance X-Wing to do either of those. So how can we create a more least privileges type of thing, right? So you're a rebel officer and you took control of a TIE fighter, right? So the X-Wings are blocked, but now you have a TIE fighter. So you still want to be able to land, but you don't want to be able to hit the, this, okay, let's see. Okay, so sorry, that was like something in the middle. So now if we have the TIE fighter, we can have the exhaust, we can still hit the exhaust port, right? And that's not good. So, okay, I see this. Can Cilium give identity at any kind of level? Pod, deployment, namespace. Yeah, it can give identity, or it's using the identities from Kubernetes and applying those. Is identity a simple label and a controller looks for those labels or something more complex? No, that's pretty much exactly what it is. It's just like a label on your like pod or your deployment, and the Cilium is like looking for those things. Okay, so right, since the TIE fighter had the right label applied to it and didn't have anything else blocking it, it was able to access not only like the landing request, but also the exhaust port. So it was able to blow up the Death Star, right? So this isn't kind of like practicing the principles of least privilege. So that's bad. So we actually want to deny things too. So if we go to this network policy editor here, oops. Let's see. So we can see this is like the kind of like visualization that I was talking about earlier. So outside the cluster, so in this namespace, anything that's org empire. So this is how our TIE fighter can access what we're doing, and it's able to attack that. But everything in our cluster isn't able to do that, and anything outside the cluster also isn't able to access the Death Star. But since we only, we said anything with the label org empire is able to make this request, that's how the Death Star got blown up. But now what we're going to do is add a layer 7 network policy to include the being able to filter by a HTTP. So let's just run this now. So we've set up this rule now. So now if we want to try to blow up the Death Star, we have access denied because that type of request is no longer allowed. So we're restricting the TIE Fighter's access to only the required API resource on the Death Star. So they can't access the whole Death Star, right? So this is the principle of least privilege. This is the advantage of being able to do things by labels and being able to filter down on that. Switching back, there's a question under GitHub/Cilium. There's no repo using Rust. Is all kernel-side BPF code written in C? Why not Rust? Considering Rust is more modern, why isn't Cilium using it? So this is what I was talking about before. So Cilium is an almost 10-year-old technology. So 10 years ago, Rust wasn't quite as popular. So that's why Cilium isn't using more Rust. I think in the future, we would consider using Rust, but right now, we have 10 years of C code, right? So we're not gonna rewrite that overnight in a different language. But yeah, there's nothing, I don't think there's anything wrong with Rust. Okay. So 3, 2, 1, next challenge.
Bill, there are a couple of questions. So if you scroll down, I'll just speak it here. One of them is from Avinesh. He says, do we support custom policies in Tetragon? If yes, how is it validated? And how does Tetragon or eBPF technology validate rules, whether they break things or not?
Yeah, so yeah, with Tetragon, you can write your own tracing policies. So there's a library of tracing policies, or you can write your own. If you're writing, so the policy library are like ones that the maintainers have written. If you're writing your own, then you're kind of on your own. So like eBPF has a verifier to make sure that it won't break the kernel. But if you're writing a tracing policy, and if you're observing if you're just observing kind of like what's happening, it'll create alert, but nothing will actually happen, so it won't break anything. But if you're actually going into enforcement, saying like if things happen, then like block this process, then you can break things. And I think that's when you need to actually understand what you're doing in the kernel, because you are modifying your kernel in a safe way, but you need to be sure that you actually want to make those modifications to your kernel. And then the other one is, what are the required skills to contribute to the Cilium project? The place that I'd recommend going is going to docs.cilium.io and then going to the development guide. So I'll drop this into, and that's a great place to get started. Okay. Then we go back to our lab here. So network policies can block or allow traffic between pods. L3, L4 cannot filter HTTP requests, but layer 7 can. And Cilium does support standard Kubernetes network policies. So let's see, now we have our final exam challenge. Let's see, the Death Star was destroyed by an X-Wing, and what does the Empire do? They built another Death Star. So it's now asking us to create a sneaky rule where we can access which restricts access to Death Star to Empire ships only. And so it's asking you to, hey, can you create a policy about this, right? So this is where you're gonna add the different, you're able to change the labels and do it. So yeah, but I don't wanna give away the answer. So I'll have you go through the lab and see if you can figure out what it is too. So with that, we don't have too much time left. So I wanna leave any time for like additional questions that people may have. I want to leave the exercise open to the reader or to anyone like you to go tackle the challenge to see if you can earn the badge. I don't want to give away the answer here. But yeah, it's been like a really quick run through of Cilium, how to get up and started with it, like some of the features that it has. I've walked you through like a little network policy demo example. What other questions do people have about the project?
I have one which I had noted down. So Ahmedabad is a city which has more of ops crowd than dev crowd. The contributing guides usually look at things from dev perspective. How can ops contribute technically to the Cilium project? Because Cilium is an umbrella. It's now an umbrella of so many projects. How could they get started?
Yeah, I think a good way is to like open issues as you're running Cilium in your clusters. If you're like testing out like release candidates and stuff and you run into issues, like people always think like, oh, I need to have like a PR for it to like count as a contribution, but like opening issues also helps because it helps us root out the bugs before they hit actually production workloads. So I think if you're in operations, a good way to get started contributing to any project is just opening issues that you run across. Then there's a question, how did you discover Cilium eBPF? What's your story with it? Can you tell me a little bit about your story in the tech world? Yeah, I guess maybe I skipped over this in the intro. So I actually don't have any background in tech. I did my undergraduate degree in biochemistry and then my master's degree in social science. So actually, I don't code at all. This is actually, you all have seen the first time I've actually run a cluster with Cilium in my life, even though I'm a maintainer of the project. I've never done it before. So I kind of got into tech by accident. I was looking for a job after doing my master's, and the company was doing this thing called Kubernetes. I thought it was a Greek island. I had no clue what the command line was. Showed up the first day, and they like said, "Okay, you're going to set up a Kubernetes cluster." It only took me 8 hours, but we got there in the end. So it was a bit of a learning curve experience along the way. But from there, I've just kind of like been self-taught, just like watching lots of YouTube videos, doing tutorials, looking at blog posts, reading things on social media. And that's how I've like really, trained myself up in the tech world. And then how I got into like Cilium and eBPF. Well, I went through a couple different startups. Startups are very good at going out of business. So I've had to kind of move from one to the next. And then finally, I ended up at CNCF, like the Cloud Native Computing Foundation, which is really the center of the ecosystem. And there I got to see a lot of different projects, interact with different people. And when I was looking for a new job, Liz Rice, who's currently my boss, and I went on some bike rides with her when I was at KubeCon. And she made a post on Twitter and said, "Hey, I'm looking to hire somebody for my team." I didn't know what Cilium or eBPF was really at that time, but I knew I wanted to work with her. And I got the job and then started to learn about Cilium and eBPF. So I really didn't know a lot about the projects before I got this job, and it's all been kind of like learning on the job. But I think that's been my whole story in tech too.
Oh, this is wonderful. Really very wonderful story.
Thanks.
Bill, I was going through some blog. I don't remember what domain it was on, but I think it was kind of a comparison between Cilium and Submariner, both of which Cilium has this cluster mesh feature, right? And Submariner is also based on the same idea. What I understood was that for Cilium cluster mesh to work, one needs to compulsorily use Cilium as the CNI plugin on the Kubernetes cluster, whereas that's not really a requirement when using Submariner, or there are other projects as well. Is that still the same, or has that requirement changed?
Yeah, you need to have Cilium as the CNI because it's providing the connectivity. I guess maybe like one thing that I can kind of say to that, there was recently a survey of like the end users of like CNCF.
Mm-hmm.
And the latest one was the CNCF Tech Rater of multi-cluster, and Cilium received the highest score for both usefulness and maturity. So an actual survey of people putting these different projects into production, Cilium comes out on top. So if you're looking at meshing multiple clusters together, like the data speaks for itself.
Yeah. Since someone's asking, I think I have one more. I was recently going through Kubernetes subreddit, and I know Reddit is Reddit, but somebody mentioned that, I think it was an ops person, and they mentioned that people are starting to add eBPF policies right, left, and center. And then things are breaking in the production environment, stuff like that. And I think my takeaway was that those kind of policies should be properly monitored before any code gets merged. But what would be your take, do you think? And the reason I'm asking this is because you just said eBPF is to kernel what JavaScript is to browser. So it's like our different frameworks of eBPF coming up every single day. I don't think that's the case, but how would you recommend people to use eBPF if they are trying to use eBPF instead of using something on top of it like Cilium or something else?
Yeah, I would say like eBPF is like a very like low level technology. So if you aren't kind of like if you're not thinking about like eBPF and you're not like programming the kernel, then like maybe it's not the right thing. You should use a higher level abstraction. I actually wrote like a blog post about this. I just put it in the chat too. I think that's actually like a good thing because it's like you can get the power of it without having to know exactly like kernel internals or being able to understand how the whole Linux kernel networking stack works. It's like the same thing if you're not, kind of like writing your own IP tables rules. You need to be doing like eBPF programming. You can take away a lot of kind of like the heavy lifting by using a higher level abstraction. I guess like the other question is like if there's like multiple eBPF like products like working together, this is like where it becomes a little bit more complicated because if they're trying to do the same thing, then the programs can run into contention. So then it's like knowing what software you're actually deploying. But I think this is like a general thing. Like you should know what software you're actually deploying into your cluster and using.
We have a few questions in the Q&A. One is, how does Cilium achieve multi-tenancy and it to be cluster agnostic? I'm not sure, Avinash. Feel free to unmute yourself, guys.
Yeah, so Cilium does multi-tenancy with network policy. I would actually recommend from the adopters page, there's a talk from Bloomberg about how they implemented. I'll put it in the chat. There's a talk from Bloomberg about how they use Cilium network policy to implement multi-tenancy, and obviously, like they're working with sensitive financial data, so it's pretty critical for them to get that right. So I'll let you, because I don't have time to go into the full answer about that. And then the other question is, based on your journey, what's your recommended way or learning path to understand eBPF? Yeah, so the first thing is go to, let me just share my screen again really quick. Is go to ebpf.io. The really easy way to get started is like this, what is eBPF page, and it walks you through at a very high level what some of these things are. And then when you actually want to start it some more, there's some labs to get you kind of like hands-on with eBPF, like similarly to what we just did with Cilium. And then if you go to the Isovalent website, there's also there's 3 books that you can do. So there's Security Observability with eBPF. What is eBPF? And both of those are shorter reports. And then Learning eBPF is like, I think like a 250-page book from Liz Rice about how actually to, really get going on your journey of eBPF. So those are kind of like the ways that I would do it. And yeah, watch the eBPF documentary. That'll really get you excited about the technology. Then another question, what are some use cases of eBPF other than networking and monitoring, or is there an unusual demo you have seen that uses eBPF? Yeah, I think that's the crazy thing about eBPF is it allows you to like reprogram everything. So if we go back to the eBPF homepage, like it says networking, observability, tracing, security. I think the coolest one that I like right now is actually around scheduling. So being able to write custom schedulers for the Linux kernel, which we really haven't been able to do. But now things like, think about like gaming. You can write a custom scheduler that speeds up, your computer, and you can have a better performance system. I think that's pretty cool too. But yeah, eBPF allows you to modify anything you want in the kernel. So there's a lot of crazy use cases that people are coming up with. Yeah. We have like 2 minutes left, so I'm happy to answer any more questions left. Or is there anything in the chat that people have?
If we have forgotten to take a look at your question in Q&A, please feel free to unmute yourself and just speak up. Okay, I guess we don't have any more questions. Thank you. Thank you so much, Bill, for taking time and talking to us about eBPF and Cilium. This was actually very fun. Great to see the use cases of Cilium. It's become a very huge umbrella compared to, so when I saw the documentary, it gives an idea about the starting phase, how things got started, and now where Cilium is. It's just so many projects doing so many things. Pretty amazing to see it. I think there is one more thing in chat. Okay, no. Yeah, I guess there are a lot of shy people here, not speaking or sharing their videos. But yeah, thank you. Thank you so much, Bill.
Yeah, thanks.
Thank you, Bill.